Alright, 9.2, angles and arc measure. Objective, Buckingham students will recognize major arcs, minor arcs, semicircles, central angles, and find the length of arcs. Okay, so central angle. This has the center of the circle as its vertex, and its sides contain two radii. That's the plural of a radius. Two radii of the circle. So here's the center of the circle, it's the vertex. Here's two radii, therefore it's a central angle, okay? That's all there really is to a central angle. It's just an angle from the center of a circle. The sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. So these three angles here have to add up to 360 because that's a full rotation. Alright, well with that information, we could probably solve this problem. So find the measure of AOD and AOE. Alright. Well, a couple things to think of. First of all, if a full circle equals 360, then we could say something else. We could say a half circle equals what? Well, it's going to equal 180. Well, this looks like a half a circle here. So we have 25x plus 3x plus 2x. Oh, that has to add up to 180. So we're just going to do some simple algebra. 25 plus 3 is 28, plus 2 is 30. And divide 180 by 30, you get x equals 6. Now that is going to be extremely helpful for answering these questions because AOD is 25 times 6. So 25 times 6 is 150, so we could say that AOD is 150 degrees. What about AOE? AOE is this thing. If we notice though, it has to be vertical to this whole angle here, which is 3x plus 2x, or 5x. Well, that's pretty easy then, because I know what x is. 5 times 6 is 30, so AOE has to be 30 degrees. Sweet. Alright, let's move on. Okay, what is an arc? An arc is the two parts that a central angle separates the circle into. So, here we have a central angle, right? Starts at A, goes to C, then to B. And so, this is an arc, and this is an arc. The small one is called a minor arc. Minor arcs have the exact same measure. We'd say it has the same measure as a central angle. So if this angle was, 80 degrees, then this arc measure is 80 degrees. And the minors are always less than 180. Okay? A major is 360 minus the central angle. Okay? So if we knew that this was 80 again, to find the blue one, we would just say it is 360 minus 80. And major arcs are always greater than 180. And like I said up here, semicircles or half circles are always 180 degrees. Okay. Congruent arc measure theorem. Basically, in the same or incongruent circles, two arcs are congruent if and only if their corresponding central angles are congruent. Corresponding central angles. So let's take a look at this picture. I guess I didn't include one, so I'm going to draw one over here. We got a circle. If these two central angles are congruent, then that means that these two arc measures are congruent. That's all there really is to it. And then also, I guess you could say these two angles are congruent, so therefore these two arcs are congruent. And if they were different circles, if the angles were congruent, then the arcs would be congruent. Pretty simple. Alright, the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. This is pretty simple. This is just like the angle addition postulate. Basically, if I was to add in some angles here, some angles here, all they're saying is the measure of AE, which is this, plus the measure of EH, which is this, has to equal AH, which is this whole thing. Pretty straightforward, pretty simple. We're just adding up all the arc measures. Alright, in circle F, the measure of angle DFA is 50. Okay, yeah, we could see that in the picture. And CF is perpendicular to FB, so that's how we get this right angle. And they want us to find the measure of arc BE, CBE, and ACE. Okay, I'm going to do the first two with you, and you guys can do the last one on your own. So, and by the way, these little symbols are not the correct symbols. It should be this. It's just kind of a little arc. That's what it should be. So BE, what does BE equal? Well, I notice that BE's central angle is right here, and it's vertical to this angle. So these, I can mark both of these angles as congruent. Oh man, I did a double, so I'll do it over here. So they're both 50, therefore their arc measures are both 50, so BE is 50 degrees. What about CBE? Well, CBE, this one is 90 plus this one is 50, so that's 140. So I can say CBE is 140 degrees. Why don't you guys go ahead and try to find ACE? Use what you know about complementary, supplementary angles and find ACE. Okay, so arc ACE is this one in red. We just have to add up all its parts. And I'm going to start with this one in the middle, which we know is 90. We also know this is a straight line that goes right through the center of the circle, so then this whole thing must be 180, right? Because two 90s make 180. Plus, we already know this is 50, so 180 plus 50 is 230. And there we go. We found its parts. Alright, example number 3. Find the measure of the central angle for each category. Okay, so this one's going to be a little bit more work, a little interesting. Basically, let's think about it this way. These percentages are all going to add up to 100. And all the angles are going to add to 360. So I should just be able to take a percentage of 360, and that would be my angle. For example, we'll start with pumpkin. The pumpkin has to equal 0.30 of 360. Well, if we just kind of multiply this out really quick, 0.3 times 360 is 108. So the pumpkin is 108 degrees. Should be that simple. Let's do another one real quick. Let's just go around clockwise. So the next one would be cherry. Well, cherry is 23%, so 0.23 of 360. What's that? I get 82.8. And so you can just keep doing this. I'm going to let you guys do the last three on your own. So you're going to find apple, coconut cream, and pecan. So go ahead and try those ones on your own and unpause the video when you're ready. Okay, so all I did again is I just multiplied the percentages by 360, and here's what I got: 129.6, 10.8, and 28.8 for the pecan. Okay, now we get to the real meat of this lesson. This is all about talking about arc length. Now, so far we've been talking about arc measure, meaning like an angle measure, but now we're going to actually talk about its actual distance. Okay, so we should be able to actually find this distance along a curve. It's pretty cool. Normally, so far, we've only been able to measure straight lines, but now we're actually going to measure curves using this pretty basic proportion. See, the idea is, for example here, if this angle is 50 degrees out of 360, then this arc length here of dA has to be the same proportion out of the whole circumference. So we could just plug things into this little formula, and we should be able to solve for the arc length. So using the image below, find the length of AD. Hey, that's the exact one I was pointing at. If FE is 15. So let's just kind of play with this. So I know I'm going to be setting up for proportion. I know I'm going to put 360 on the bottom here. And I want the arc measure. Well, we already know that AD is 50 degrees. So put a 50 there. L for arc length is what I'm trying to find. And on the bottom, I'm going to put 2 pi times the radius. Well, the radius in this situation is 15. So really what this is just the circumference. So what is the circumference? Well, 2 pi times 15, that's 30 pi, right? So that's what I'm going to put here is 30 pi. All right. This is a pretty basic proportion. Let's just go ahead and work it out. First of all, I think these zeros can reduce, right? So I have 536 equals L over 30 pi. I also can just multiply both sides by 30 pi. And when I do that, let's clean it up a little bit to show you what I got. I have 30 pi times 5 all over 36. Because remember, when I multiply, it just goes on top. Okay? And this whole thing equals my arc length. Alright, well I can actually reduce a little bit more because a 6 goes into 30 and 36. So let's take a 6 out of that. That goes in there 5 times. That goes in there 6 times. And so I'm going to write what I got. I got 5 times 5, which is 25 pi over 6. And that is the arc length. I know you think that we want to put that in a calculator and get a decimal answer, but no need to get some weird nasty decimal when we can just leave it exactly like this. In upper mathematics, we love answers like this. We don't like answers in decimals as much. So this is fine. 25 pi 6. We're done. Alright, I want you to try practice number 4 on your own. It says, using the image above, find the length of arc CBE. And now they're saying that FE is 20. So remember, I have changed the radius for you guys. The radius is now 20. It's not 15. Go ahead and give it a try, and we'll check back in a second. Okay, so I said 140 over 360 has to equal the arc length over 40 pi. From there, I just reduced it by 10, which got rid of my zeros. Multiply both sides by 40 pi to cancel out these 40 pi's. From there, I saw I have a 40 pi over a 36. I could take a 4 out of both of these, so that makes 10 over 9. So 10 times 14 is 140 with the pi up top, and a 9 in the denominator, and I am done. Okay, so 2 things left. I want you to find the arc length of a central angle of 129 degrees. So we know the central angle is 129 degrees. So you're going to be using this formula. And the radius is 10. Leave your answer in terms of pi. So that should be pretty straightforward. And then also remember to give me at least one question that you have from the notes. If you don't have a question, then you can create your own question from these types of notes. Alright, see you guys on the next video.